Welcome to this explainer. Today, we're going to transform a moment of sheer panic into a seriously empowering troubleshooting session. We are decoding the secret language of your TCL air conditioner. We're going to take those confusing, cryptic letters and numbers flashing on your unit and turn them into a clear, actionable guide. The goal, getting your cool air flowing again as quickly as possible. So let's dive right into this. Picture this scenario. It is a scorching hot day. You're sweating, you reach for the remote, and instead of that amazing blast of cool air, your AC just sits there, and it's flashing these weird letters and numbers on the display. It's incredibly frustrating, right? Your first instinct is probably to assume the whole machine is just completely fried and you're about to be handed a massive, painful repair bill. But take a step back. What is your AC actually trying to tell you? Here's a little secret for you. This is absolutely not a death sentence for your appliance. It's actually a feature, not a bug. Think of it exactly like your car's check engine light. The system has recognized a very specific internal issue, and it's practically handing you the diagnosis on a silver platter. Our only job today is to translate that diagnosis so you know exactly what to do next. To do that, here is our roadmap for decoding these error families. First, the secret language of ACs. 2, E codes for sensors and systems. 3, P codes for power and protection. 4, F codes and portable units. 5, Wi-Fi codes, and why you really shouldn't panic about those. And finally 6, troubleshooting, deciding between a DIY fix and calling a pro. Let's get right into it. Section 1, the secret language of ACs, understanding the hardware. Before we look at the specific error codes themselves, we really need to understand a couple of intimidating acronyms that pop up constantly in the technical manuals. The two big ones you'll see are the PCB, which stands for Printed Circuit Board, and the IPM, or Intelligent Power Module. You can basically think of the PCB as the central computerized brain of your AC. It tells everything else what to do. The IPM, on the other hand, is the power regulator. It manages the heavy electricity needed to actually run the compressor. So when the manual mentions a PCB or IPM failure, it means the fundamental communication or power routing right in the brain of your unit is malfunctioning. And as a general rule of thumb, when the brain is broken, you're almost certainly going to need a professional HVAC tech to replace the board. Section 2, E codes, error sensors and systems. Let's move to our first major family of errors. The E codes generally indicate an electrical communication fault or some kind of sensor issue somewhere in the system. Notice how logical the system actually is once you break it down. The crucial point to take away here is that E1, E2, and E3 are basically identical issues. They all indicate that a temperature sensor has an open or short circuit. E1 is your indoor room temperature sensor, E2 is the sensor on your indoor pipe coil, and E3 is the sensor on the outdoor coil. If your unit doesn't know how cold or hot the air is because these sensors are dead, well, it can't regulate the temperature. It's a highly precise alert telling a technician exactly which wire they need to check. However, as we look at E6, E9, and EE, the severity really scales up. If you see an E6, you are dealing with a jammed or failing indoor fan motor. An E9 points right back to that intelligent power module we just discussed, meaning you've got a defective module board. And an EE code, that is a total EEPROM failure. It means the actual physical memory chip holding your AC software is burned out or damaged. If any of these 3 codes flash on your screen, consider them immediate red flags. You need an electrician or an HVAC pro, definitely not a DIY weekend project. Section 3, P codes, power and protection. Let's shift gears and explore the P codes. The P here essentially stands for protection. When you see a P code, your AC is quite literally shutting itself down to save its own life. This is a brilliant example of modern built-in safety. If you get a P1 or P2, your unit isn't necessarily broken at all. Rather, it's detecting dangerous voltage or current spikes coming from your home's power supply. It cuts out specifically to prevent its internal motor from blowing out, or worse, starting an electrical fire. Meanwhile, a P5 indicates subcooling. That is a major hint that your system has a low refrigerant charge and desperately needs to be topped off. But hey, good news! Not all P codes require a professional. For P4 or P6 codes, the system is simply telling you it's overheating. This is often an incredibly easy DIY fix. You literally just need to turn the system off, let it rest for maybe 15 to 30 minutes, and check the air filters. Very often, a thick layer of dust is choking the airflow, which causes the condenser to overheat. Just clear away that dirt, restart the unit, and boom, you've just saved yourself a $100 service call. Section 4, F codes and portable units. Next up, we dive into the complex F codes, which are typically reserved for inverter split systems, as well as the unique codes found exclusively on TCL portable freestanding units. Now, this flowchart is straight out of the service manual for an F5 power factor correction code. It shows exactly how an AC thinks and tests itself. When an F5 is triggered, technicians followed this exact logical loop. The system tells them to switch the unit off for 3 minutes and then turn it back on. Why do that? Well, to see if the power spike was just a random fluke in the neighborhood grid, or if the code persists. If it persists, that proves it's a permanent PCB failure that needs a replacement part. It's essentially built-in scientific deduction. Now, if you happen to own a portable unit, your codes are a bit different and honestly, usually far less scary. Codes like FD or P1 aren't mechanical breakdowns in any way. They're really just status reminders. Because portable units sit on your floor, they collect condensation in a little internal reservoir. FD simply means full tank. You literally just need to unplug the unit and drain the water. Similarly, DH just means dehumidifier mode is currently on, which is a reminder to make sure you've attached the exhaust hose. But check out this one, the LT code, which stands for low temperature. If you run your portable AC way too hard in heavy humidity, it literally gives itself a brain freeze. Just like when you drink a milkshake way too fast. Ice actually builds up on the internal coils, but the AC is smart enough to stop blowing air and initiate a frost protection defrost cycle. Unplugging it for a half hour is usually all it takes to melt that ice, reset the appliance, and get it working perfectly again. Section 5. Wi-Fi codes. Don't panic. Moving on to our penultimate category, we really need to talk about the specific letters that show up strictly on Wi-Fi-enabled smart appliances. This is a huge source of confusion for new owners. If you turn your unit on and immediately see PP, SA, CF, or AP, take a deep breath. Do not panic. These are not errors at all. They are simply status updates telling you what the internal wireless card is doing at that exact moment. PP and SA mean it's actively searching for your home internet. CF means it's ready to connect to your router, and AP means it's acting as a mobile hotspot. The biggest takeaway here? If you aren't even using the Smart App features, you can completely ignore these letters. Your AC is going to operate normally regardless. Section 6. Troubleshooting DIY versus Pro. To wrap up our explainer today, we need to clearly draw the line between what you can safely handle at home to save some cash and when you absolutely positively must call in professional backup. So here is the final boundary. Resting the unit to clear P6 overheating code, washing out a dust-clogged filter, or draining an F-full water tank, those are incredibly easy DIY weekend tasks that anyone can handle. But if you have an EE code for a burned memory chip, an E1 open circuit temperature sensor, or an E9 intelligent power module failure, stop immediately. Those involve high voltage and highly sensitive computer boards. That strictly requires an HVAC engineer. Don't risk it. Oh, and here is a fantastic pro tip hidden deep in the source manual. Your outdoor unit actually has a secret language of its own. It uses a blinking LED light on the main board to communicate. If that outdoor LED light blinks exactly 23 times, it means the entire system is short of Freon. That is a definitive, undeniable sign that you need a professional to come out, find the leak, and recharge that refrigerant gas. So, we come back to our core mindset shift. The next time your TCL air conditioner flashes a cryptic code on a scorching hot day, don't panic. Just ask yourself, is it truly broken or is it just trying to protect itself from a power spike or a dirty filter? Grab your manual, use the knowledge from this explainer to decode the matrix and take the right steps to get your cool air flowing again. It really makes you wonder, though, if your AC is this smart, what other secret languages are the rest of your home appliances speaking right now?